Welcome again to my channel. This is the way we learn mathematics, and let's learn about equality of two complex numbers. As we know, the complex number is a number of the form a plus bi, where a and b are real numbers and I squared equals -1. For example, 2 plus 3i, 7 minus 8i, 4i, 8 minus 4i. Those are examples of complex numbers. I'm going to show you equality of two complex numbers. Let's see the definition. For two complex numbers to be equal, the real parts must be equal and the imaginary parts must be equal. That is to say, if a plus bi equals c plus di, these are two complex numbers, then a equals c and b equals d. A is the real part of the first complex number and c is the real part of the second complex number. B is the imaginary part of the first complex number and d is the imaginary part of the second complex number. The complex numbers a plus bi and c plus di are equal if a equals c and b equals d. Let's explain this by using examples. Find the real numbers x and y such that 4x plus 2yi equals minus 8 plus 10i. We have to solve the equation obtained from real parts and imaginary parts. Here, real parts are 4x and minus 8, and imaginary parts are 2y and 10. So we have to equalize 4x and minus 8. Again, 2y and 10. 4x equals minus 8. X equals minus 2. And 2y equals 10. By solving, we obtain y equals 5. Therefore, x equals minus 2 and y equals 5. Let's see the next example. Example number 2. Find the real numbers x and y such that x plus 4y plus xyi equals 12 minus 16i. Here we need to use the equality of these two complex numbers. Real parts must be equal and imaginary parts must be equal. That is to say, x plus 4y equals 12 and xy equals minus 16. We have two simultaneous equations. We have to find the values of x and y. Let us use substitution method. From equation 1, when you find x is equal to 12 minus 4y. And let me call equation 3. Replace equation 3 in equation 2. This gives 12 minus 4y times y equals minus 16. This is because 12 minus 4y is equal to x, and equation 2 it is xy. So where we have x, we write 12 minus 4y. So we replace x by 12 minus 4y in equation 2. After replacing, we obtain 12 minus 4y times y equals minus 16. Removing brackets, we obtain minus 4y squared plus 12y plus 16y equals 0. Then we can divide both sides by negative 4 and we obtain y squared minus 3y minus 4 equals 0. We can solve this quadratic equation by factorizing. This gives y minus 4 times y plus 1 equals 0. And from this equation, y minus 4 equals 0 or y plus 1 equals 0. When you have a product equation, each factor must be equal to 0. That's why y minus 4 equal to 0 or y plus 1 equals 0. Then we are going to solve each equation.
For y minus 4 equals 0, y equals 4.
And for y plus 1 equals 0, y equals minus 1. Then values of y are obtained. The next is to find the values of x. We can use equation 3 since x equals 12 minus 4y. For the first one, y equals 4, then x is equal to 12 minus 4 times 4, and this is 12 minus 16. 4 times 4 equals 16. Then 12 minus 16 equals minus 4. And for the second value of y, which is y equals minus 1, then we have to replace y by its value using equation 3. Here, x is going to be 12 minus 4 times minus 1, since y is equal to minus 1. And this is equal to 12 minus 4 times minus 1. When we take minus 4 times minus 1, we obtain plus 4. And this is equal to 12 plus 4, which is 16. Then the required values of x and y are x equal to minus 4 and y equal to 4, or x equals 16 for y, which is equal to minus 1. So when we have a problem like this example, we need to use definition of equality of two complex numbers, where for the two complex numbers to be equal, the real parts must be equal and the imaginary parts must be equal. Let's see an exercise. Given z equals a plus b minus 4i and w equals 2 plus bi, then find the values of a and b if z equals w. Here we use the equality of two complex numbers. Try this exercise and check the solution in a few seconds.